A big part of the value that our systems bring is digital switching. What digital switching really means is that you're eliminating complex harnesses that include fuses and relays for each individual circuit. Instead, you go to something like a power distribution module that is solid state and controlled over the CAN bus. What that allows you to do is put all of these keypads and multiple displays onto a single bus that just consists of 2 wires. So a 16-button keypad like this one only requires 4 wires to be set up. You have power, ground, and then your CAN. When we put everything on the same CAN network, they're able to control the same outputs. This 5-inch display we have set up as a remote. So I can turn on an output from this remote, and that syncs with the keypad and turns on over there. Then the keypad can turn it off. And any of these devices on the bus can be configured to control those outputs. From the display itself, we can set up those outputs. For example, I can configure an output, name it, give it an icon on the display. I can select the current limit, which is like a digital fuse, and I can select the type. So since we're doing all of our current monitoring through the display, you're also able to reset an output automatically or alert the user that they tripped a fuse. For the types, you can set those up based off of your application and your need. So our basic types are momentary, latch, low, mid, high, things like blower and bilge for automatic outputs on marine, always on, H-bridge, and more logic can be designed around that too for custom applications. Example with like a low, mid, high, this button over here, if I press it once, it comes on 33%, twice, 66%, third time, it's 100% on. The keypad itself gives the user feedback on what the output is doing.